This is Chemistry 5.5 Crude Oil, Fuels and Organic Chemistry Foundation Tier Past Paper. So the first question, the fire triangle is shown below. Describe what the fire triangle shows, the three substances which are needed to start a fire. Use your understanding of the fire triangle to state how each of the following firefighting methods worked. By placing a heatproof mat over a beaker that contains burning ethanol, if you place a heatproof mat over it, it will remove oxygen. No more oxygen can get into the fire. Using water on a bonfire, that removes the heat. And cutting down trees to provide a fire break in a forest removes the fuel. So if you remove any part of the fire triangle, it will mean that the fire will stop. A cook notices that a frying pan contains oil, has caught fire. He decides to get the fire extinguisher to put out the fire. Choose from the following box the type of fire extinguisher that should not be used. Water should never be used near a fire containing oil or an electrical fire. Question number 2 then is looking at the structural formula of 4 organic compounds. So there's the structural formula of 4 organic compounds. Give the chemical name for compound B. So compound B has got a double bond. So straight away you know it's an ene because it's got a double bond. So it's an alkene. And then it's got 2 carbons, so meth, eth. So it'd be ethene. Give the letter of the compound that is not a hydrocarbon and give a reason for your answer. D, because hydrocarbons contain only hydrogen and carbon. D contains carbon and fluorine. Give the letter of the compound that will undergo additional polymerization and give a reason for your answer. That is B, double bond allows for polymerization to take place. So that would then get rid of the double bond and go into the brackets. The molecular formula of propene, so 3 carbons and a double bond, ene, a double bond, is C3H6. Draw the structural formula. So you could have put the double bond by there if you wanted to, but there you go, that's the structural formula. Question number 3 then is looking at the reactions that alkenes can undergo. So the following diagram shows some reactions of ethene, as shown here. Complete the diagram by giving the missing structure. So you're adding bromine water, which means you're adding bromine to the double bond. This can happen at room temperature. No real conditions are required. So if you get rid of the double bond, you'll end up with 2 bromines instead. Describe what we've seen during the reaction between ethene and orange bromine water. The orange bromine water would turn colourless, which indicates that there is a double bond. Give the names of the 2 types of reactions labelled in A and B. So A is hydration, because you're just adding more hydrogens over the bond. So A is hydration, and reaction B, that's undergone addition polymerization and become a polymer. So question number 4. Crude oil is a mixture of hydrocarbons. State how it is formed. Remains of dead plant and animals applied to intense heat and pressure over millions of years. That should say, and you make sure you've got to always remember, dead marine. Got to make sure that you put the marine in there. So remains of dead marine plants and animals applied to intense heat and pressure over millions of years. The table shows the properties of some fractions that can be attained from crude oil. So different fractions, different carbon sizes, boiling points, the colour of the fraction, viscosity means how easily it runs, and how easily it burns. So quite an intensive table there with a lot of information. Describe how any 2 properties of crude oil fraction depend on the size of the molecule. So here's the size. These ones up here are smaller. These ones down here are much longer. So different things that could happen. Viscosity increases down the group, so they get more viscous as you go down the group, which essentially means less runny, thicker. Another property you could have done is the boiling temperature. So as you go down the group, the boiling temperature increases. These ones are harder to boil. They've got higher boiling temperature than the ones at the top. Part 2 to this question then is, it's not part, it's a different question as well. Crude oil can be separated using a simple mixture called fractions, which contain hydrocarbons with boiling points of similar range. The graph shows the boiling points of hydrocarbons containing 1 to 12 carbon atoms. Give the number of carbon atoms in the hydrocarbon which has the lowest boiling point. So the lowest boiling point is going to be the one that's closest down here, and that is 1 carbon. State how boiling point changes as the number of carbon atoms increases. The boiling point also increases. A company wants to produce a fraction with a boiling point of a range between 120 and 140. Give the number of carbon atoms present in the hydrocarbons found in this fraction. So as you can see here, I've drawn some lines between 120 and 140, and the biggest range there would be 8 hydrocarbons. Plastic has replaced glass for making some plastic drink bottles. Apart from cost, give one property of plastic that makes it suitable material for making drinking bottles, less fragile. Okay, so if you're using glass, it could break. Glass bottles are also harder to reuse. Plastic can be reused. Question 6. Plastics such as polyethylene and polystyrene are widely used every day. The table shows the properties and some common uses of polyethylene and polystyrene. So there's some examples there. Use the information in the table to give a reason why polyethylene is used to make carrier bags and bin liners. So you're looking for a use, a property that makes it good for its use. So flexible, can be moulded into shape to be placed in bins. Also means that it can take the weight of the shopping that you put in it. Polystyrene is used for disposable cups, easily squashed, which is a property there, can be disposed of. State why the use of plastics causes environmental problems and give one way of overcoming these problems. Non-biodegradable. So that's a big problem with plastics. They're really hard to break down. It takes thousands of years for them to degrade, essentially. They fill up the landfill sites. One way that we're overcoming this is to recycle them and reuse them, so there's less of them going into our landfills. The second part of this question then is looking at making polymers. So polyethylene can be made from ethene as shown in the following diagram. So these are all ethenes. You break the double bond and they make polyethylene, which is a long chain polymer. Use some of the terms given in the box below to complete the sentence that follows. Ethene is a small reactive molecule known as a monomer. So each of them is a monomer, 1. Each of these is a monomer, 1 of them. Many of these molecules join together in a process called polymerization to produce a long chain molecule known as a polymer. And then the final. Okay, next question is a 6 marker. Many car companies are manufacturing hydrogen fuel cars. Describe and explain the advantages and disadvantages of hydrogen as a replacement for petrol and diesel cars. So the first thing I did is a 6-mark question, so I need 6 bullet points. Hydrogen can be used as a fuel, so I wrote the equations. You essentially add hydrogen and oxygen together, and that makes energy and water as the only product. Now that's a bit different from the combustion of other fuels, which we would know you make carbon dioxide if it's complete combustion. Disadvantages then. Production is very expensive to mould these two together and it requires an awful lot of electricity. Storage, storing these and the energy that's made requires pressurised gas canisters, and it also requires a catalyst. So even though a catalyst can be reused, they are expensive to source. Advantages of using hydrogen as a fuel. Water is the only product. Renewable source of energy and easy ignition. So this easily lights up to make the energy. So you're not using an awful lot of heat to make the ignition start. Question number 8 then, again, another crude oil question. Crude oil, it can be separated in fractions using fractional distillation. You can see that these kind of questions come up all the time. Explain why it's possible to separate crude oil using this process. Fractions have different lengths of hydrocarbon chains which have different boiling points. So the shorter your hydrocarbon chain, the lower your boiling point is. So that's how we separate the crude oil, which is essentially a mixture of hydrocarbons. Napar is one fraction that is not usually used as a fuel. It contains dectane, which can be further processed by cracking, as shown. So cracking can break down dectane into octane and ethene. This ethene then can be used to make plastics. This octane is more useful as a fuel than the dectane. State how the process is carried out and why it is important. So, the conditions you need are heat and a catalyst. It breaks down large, less useful fractions into smaller and more useful ones. Increases useful fuel from crude oil, so it just increases the fuel that is useful to us. Raw material, alkene, used to make plastics, less waste, more profit. So that again, so both of these then can be used to make something. And then finally, last question then, question number 9, another crude oil question. As you can see, this question has been asked twice in this past paper. Crude oil is the source of some very important fuels. State how crude oil was formed. Remains of marine life and plant animals. No oxygen, heat, and no oxygen, and then intense heat and pressure over millions of years. Crude oil is a mixture of compounds called hydrocarbons. They are separated into different fractions in a fractionating column. State what happens to crude oil in X before it is allowed to enter the fractionate column. So the crude oil here is heated up to roughly 350 degrees, and that means it'll evaporate. It turns from a liquid to a gas. It evaporates. Hot gases rise, so they've got less dense. They rise up, and that's how they separate when they condense back into their liquid form. State the properties of hydrocarbons which allow them to be separated using this method. Each hydrocarbon has a different boiling point. So things with low boiling points will separate here. Higher boiling points will separate. Low boiling points up here, high boiling points down here. What is a hydrocarbon? A compound made of only hydrogen and carbon.